Okie dokie. Back to notes 11.1 part 2, and I'm going to focus on this part of your notes, this potential energy graph. And I want you to think back to first semester. In first semester we drew a graph similar to this. And what this said is, in a chemical reaction you have reactants and you have products. And you have potential energy that's stored between the bonds of these reactants and products. And if you end up with less energy in your products, less potential energy in your products than you do with your starting reactants, then you get a release of energy here. That release of energy is called your delta H. And if it's an exothermic reaction, your graph looks like this. Okay, you have the starting reactants higher on the graph in terms of potential energy than the products that have a lower potential energy. Now, why does the graph look like this? Why does it go downhill like this? Well, we can actually now calculate what's going on very specifically and get an understanding of why that is, why these graphs look the way they do. We look at the reaction CH4, the combustion of methane and oxygen. And in order for this reaction to take place, we need to break several bonds. First of all, we need to break the carbon-hydrogen bonds. And how many of them are there? There's 4. So we need to break 4 carbon-hydrogen bonds. Okay. And that requires this amount of energy to do that. Here we're adding that energy into the system. This is okay, you're adding energy into that system. How much energy? Well, let's look and see. Each carbon-hydrogen bond requires 413 kilojoules per mole of energy to break that bond. Kilojoules per mole. What else do we have to add energy? How much? What else do we have to do to get this reaction to move forward? We have to add energy to break these O2 bonds. Okay, so we're adding energy here to break these O2 bonds. And how many of them are there? There's 2. Okay, we have to add energy to break these bonds. How much do we have to add? We have to add 495 kilojoules per mole. Okay, so then what happens? Well, we form, in this case, 2 CO double bonds form, right? Because we get CO2. If we look back at our equation here, this is our equation now. Okay, we form 2 CO2 molecules. And what's the value of that energy? 745 kilojoules per mole. So that actually releases more energy than either one of these two, doesn't it? Hence the longer arrow. And then what else happens? We form four OH bonds. Okay, I'm going to write in these values now, just so I know I said them verbally, but let's go ahead and write them in. Okay, so to break 4 CH bonds, we had to add in, how much was it? 413 kJ per mole. Okay, that's indicated by this arrow. We also had to add in that's times 4, right? Because there's 4 of them. And we said that equals 1652. We also had to add in the amount of energy needed to break these 2 oxygen double bonds. And that's 2 times 495. Which we said was 990. Okay, so this amount of energy right here, this positive amount of energy right here, is less than the amount of negative energy that's released. Okay, when these 2 CO bonds form, there's a massive amount of energy released. And that's going to be 2 times, here I'll write it down here, 2 times 745. 2 times 745, which was, we said, negative, and that's, sorry, negative 745. And that's going to be negative 1490. Because it's being released, right? And 4 times a negative 467. And we said that again, it was 1868, negative 1868. Okay, so now let's just look. We put energy in to break these bonds, but the amount of energy that we put in to break the bonds is less than the amount of energy that's released when the new bonds form. And as a result, this graph, you end up with this right here. Look, check this out. It's pretty cool. You end up with this difference right here. This difference between this point and this point. Okay, this difference here is your delta H of reaction. Okay, that's the difference between the amount of energy that you put in versus the amount of energy that comes out. Okay, in this case, more energy comes out, and it's an exothermic reaction. Okay, it releases heat. Okay, and again, if you wanted to know what the exact amount was that was released, if we take 990 plus 1625 and then subtract 1490 plus 467, we end up with a grand total of negative 716 kilojoules per mole released. Okay, why? Because more energy came out than what we put in. That's why. And that's why these graphs look like this. Okay, that's why your graph, this is a very simplified version. Okay, that's why your graph looks like this. Alrighty, I'm going to go ahead and stop this video here, and then we'll try to finish the notes in one last video.